Inside this e-waste recycling factory, old smartphones are transformed into valuable metals, plastics, and battery materials.
A discarded smartphone contains many material streams that can return to manufacturing.
The process begins when collected old smartphones arrive at the recycling facility. Old phones are loaded onto a receiving conveyor for controlled intake. Each batch is weighed to measure incoming material and recycling yield. Batch registration helps track recovered materials through the factory.
Safety inspection removes damaged devices before disassembly begins.
Phones with damaged batteries are isolated for special handling.
Manual sorting separates smartphones from cables, chargers, and accessories.
Phones are graded so reusable parts and hazardous batteries can be removed first.
Manual disassembly begins at anti-static workstations. The back cover is removed to access the battery and circuit board.
Internal connectors are disconnected before components are removed.
Lithium batteries are removed first because they need separate safe processing. Removed batteries are stored separately in fire-resistant containers. Screens are separated so glass and display materials can be handled apart.
Removed screens move into a separate glass and display material stream.
The main circuit board contains copper and precious metal-bearing components. Circuit boards are separated because they contain valuable, recoverable metals.
Small modules are removed and sorted for specialized processing.
Metal frames are separated from plastic housings before bulk processing. Plastic housings move into a dedicated sorting and pelletizing stream. After manual disassembly, each material stream follows a different recycling path. Batteries are stored safely before controlled discharge and processing. Controlled discharge reduces energy before battery recycling.
The batteries are discharged inside a controlled safety system.
Discharged batteries enter an enclosed shredding system. Battery shredding is enclosed to control dust and safety risks. The valuable battery powder, called black mass, is collected in sealed drums.
Black mass samples are checked before shipment to battery material recovery.
Battery-free phone fractions move to mechanical shredding. The enclosed shredder breaks device parts into smaller, recyclable fragments. Dust extraction helps control fine particles during mechanical recycling. Shredded fragments are spread evenly before metal separation begins. Magnetic separation removes steel and other ferrous metals.
Separated steel pieces collect in a dedicated metal bin.
Eddy current separation pushes non-ferrous metals away from lighter materials.
The non-ferrous stream contains aluminum, copper, and other valuable metals.
Air classification separates lighter plastics from heavier metal-rich fragments. Optical sorting helps separate materials by visual and spectral properties. Plastic-rich fragments move toward granulation and pelletizing. Separated screen glass is collected as its own recycling stream.
Aluminum frames and light metal parts are separated for recycling.
Aluminum pieces are compacted into blocks for transport. Copper-rich fragments move into a dedicated copper recovery line.
Cable stripping separates copper wire from plastic insulation.
Copper-rich material is granulated into small recoverable particles.
Recovered copper granules are collected for reuse in manufacturing.
Circuit boards are sorted because they contain valuable metal-bearing components.
Board depopulation removes components from printed circuit boards in a controlled system.
Components are removed from boards before metal recovery.
Recovered components are sorted for different metal recovery streams. Depopulated boards are shredded to prepare for material separation. Screening separates board fragments into metal-rich and non-metal fractions. Selected board fractions become a precious metal-bearing concentrate for controlled refining.
Precious metal-bearing concentrate enters a sealed industrial refining system.
Controlled smelting and refining recover metal-bearing material in a safe industrial setting. The process produces a generic precious metal-bearing material for further certified refining.
Precious metal-bearing material is sealed for certified downstream refining.
Recovered copper can be collected as granules or prepared as copper material for reuse.
Aluminum blocks are inspected before packaging.
Sorted plastic housings enter a granulator for size reduction.
Granulation turns phone housings into uniform plastic flakes.
Plastic flakes are cleaned and dried before pelletizing. The pelletizer turns cleaned plastic flakes into reusable plastic pellets. Recycled plastic pellets are packed for reuse in manufacturing. Separated screen glass is prepared as a recycled glass material stream.
One old smartphone can become several recovered material streams.
First stage receives, weighs, registers, and safety checks old smartphones. Manual disassembly separates valuable and hazardous components before mechanical processing. Batteries follow a separate controlled path to recover black mass material. Mechanical separation turns shredded phone material into cleaner recycling fractions.
Circuit boards are processed separately because they hold the richest metal fractions.
Copper and aluminum become clean material streams for reuse. Plastic housings and screens also become separate recycling streams.
Precious metal-bearing concentrate is handled in a controlled industrial recovery system.
Quality control checks every recovered material stream before shipment.
Recovered materials are packed according to their material type.
Copper granules are packed for use in new manufacturing supply chains.
Battery black mass is sealed for downstream material recovery.
Recycled plastic pellets are packed for reuse in plastic manufacturing.
Compressed aluminum blocks are palletized for transport.
Precious metal-bearing material is stored securely before certified downstream refining. The warehouse stores recovered materials by type before shipment. Inventory tracking connects recovered materials back to processing batches. Recovered materials are staged at the loading dock for shipment. Recovered materials leave the recycling factory for new manufacturing supply chains. The recovered materials are shipped to become part of new products. Every old smartphone contains valuable materials hidden inside.
Batteries are valuable, but must be removed and handled safely.
Circuit boards are one of the richest material streams in smartphone recycling.
Copper granules are one of the most visible recovered materials.
Plastic housings can become pellets for future plastic production.
Battery black mass can be processed further for critical battery materials. Circuit board concentrate can contain precious metal-bearing material for certified refining.
Aluminum frames are compacted into blocks for transport.
The value of e-waste is revealed only after safe separation and recovery.
Worker safety is essential because e-waste contains batteries, glass, dust, and sharp metals.
Enclosed machines and extraction systems help control dust and emissions.
Disassembly benches are cleaned to prevent material mixing between batches.
Mechanical equipment is checked regularly to keep recycling safe and consistent.
Battery processing areas are checked carefully after each production run.
Safest order is to remove the battery before mechanical processing. Shredding is used only after batteries and major components are removed. Different separators recover steel, non-ferrous metals, plastics, and glass.
Circuit boards are processed separately because they contain dense metal-bearing material.
Battery black mass is collected for downstream recovery of battery materials.
Copper recovery turns wires and connectors into reusable copper granules.
Plastic housings can become pellets for new plastic manufacturing.
The raw material is not ore from the ground, but discarded technology.
Disassembly reveals the different material streams hidden inside a phone.
Copper is one of the major recoverable metals in old electronics.
Phone batteries can become a source of battery material for future recovery.
Precious metal-bearing material comes from selected circuit board concentrate.
Recovered materials can re-enter supply chains for batteries, electronics, metals, and plastics. The finished output shows how old smartphones become valuable recovered materials.
Warehouse stores recovered materials before they move to new manufacturing. Recovered materials leave the recycling facility for downstream industrial use. This is the full journey from discarded smartphones to recovered industrial materials. The key steps are receiving, safety inspection, disassembly, battery handling, shredding separation, material recovery.
Before recycling begins, old smartphones must be safely opened and separated into material streams.
Batteries follow a controlled path because safety comes before material recovery. Mechanical separation turns mixed fragments into cleaner metal, plastic, and glass streams. Circuit board processing creates copper-rich and precious metal-bearing recovery streams. Recovered materials are inspected and packed before returning to industrial supply chains.
What looks like waste can become valuable material when processed safely.
Waste recycling is not one machine. It is a coordinated system of safety, separation, recovery, and quality control.
This is how old smartphones can become copper, aluminum, plastic pellets, battery material, and precious metal-bearing concentrate.
From discarded electronics to valuable recovered materials, every step depends on safe handling, precise separation, and controlled recovery. Thank you for watching Mega Processing Tech. Subscribe, like, share, and comment what recycling factory we should explore next.